Yeah, good morning, friends. Yeah, we are in the process of re-uploading the missed videos from my channel page. As you know, yesterday I uploaded part Java programming, part 1 of 33. As you know, there are 4 videos. The first 4 videos are missing from the channel page. We have observed, and I have made thorough investigation and search, but I could not figure it out. I could not locate it. So that's why yesterday I uploaded Java programming part 1 of 33. Today now I am uploading Java programming part 2 of 33. Java programming part 2 of 33. In another 2 days time I will upload the next third as well as fourth, don't worry. Now look, in this video also, as I said, we are dealing quite a lot of theory part. Theory part in the sense that we are discussing the features of the Java language in great detail. For example, in this video, we will be coming across features like applets. In fact, we are telling you the story of the rise and fall of the applet technology. Originally when Java came, Java was very much heralded for its applet technology. Applets are nothing but small applications which you can download from the net and run in a browser. Fine. Yeah, in the initial state it was a very minor technology, and the people and the audience liked the Java because of this applet technology, that feature. That feature was very much amusing and very much unknown to other languages. That's why Java is called the internet language. Its connection with the internet was through this applet, to be frank. It's called the internet. Java is called the internet language. So it had great connection with the internet. Okay. That is one aspect. The rise and fall of the applet technology. Today applet technology is very much changed. So that we are discussing. Another thing is the security aspect of the Java language. We discussed that also at great length in this particular video. Another very important aspect is the portability of the Java language. Java became famous because of its portability concept, because you can just run your code on any operating system, whether it is Windows, whether it is Macintosh, whether it is Linux or any other thing also. You write your code just once. That's why write once, run anywhere. Write once, run anywhere. This is possible because of the so-called bytecode technology of Java. Bytecode technology of Java. We are discussing that bytecode technology and the slogan, write once, run anywhere. Java is famous for that. You can just write your code only once. There is no need of making any iota of changes. Whether you run it in Windows or in Macintosh, fine, no problem. Because it is platform independent language. So this portability concept is very important. That's why we are calling it Java as a platform independent language. So there are so many features. Another important aspect of Java is the server side aspect of Java. To be frank, Java became famous because of its server side technologies. So in that area, we are discussing about the so-called servlet technology. An introduction to the servlet technology also is discussed in this video. So that is very important too. So I suggest that you don't miss any single slide in this video also. Even though there is no programs, still the theory behind, the theory which I am explaining is very important to understand the different aspects of the Java language. So don't miss this part 2 also. So today we are actually uploading Java programming part 2 of 33. In another 2 days we will be uploading the third part as well as the fourth part. From fourth part onwards, you will be getting the scenario of how to install the Java software and a suitable ID like that. So this next one, the third part also is full of discussions regarding the different aspects of the Java language. When it comes to the fourth part, we actually tell you how to exactly download the Java software and install, and a suitable ID. In fact, we are actually using the Eclipse ID. All those things are explained in great detail in part 4. So this is today we are actually uploading Java programming part 2 of 33. Fine. Good luck. Yeah. Impact of Java on the internet. Now we are discussing the impact of Java on the internet. The internet helped launch Java to the forefront of programming and in turn had a profound effect on the internet. In addition to simplifying web programming, in general, Java innovated a new type of networked programs called the Applet that changed the way the online world thought about content. Java also addressed some of the hardest issues associated with the internet. See, look, that is nothing but portability and security. What is it? Portability and security. Fine. Yeah, Java applets. We are now coming to the point of Java applets. At the time of Java's creation, one of the most exciting features was the applet. One of the most exciting features was the applet. An applet is a special kind of Java program that is designed to be transmitted over the internet and automatically executed inside a Java compatible web browser. If the user clicks a link that contains an applet, the applet will download and run in the browser. Fine. That is great. Applets were intended to be small programs. They were typically used to display data provided by the server, handle user input, or provide simple functions such as a loan calculator, that execute locally, rather than on the server. In essence, the applet allowed some functionality to be moved from the server to the client. That's great. From the server to the client. Yeah, Java applets continued. The creation of the applet was important because at that time it expanded the universe of objects that can move about freely in cyberspace. Look, in general, there are two very broad categories of objects that are transmitted between the server and the client. Look, passive information and dynamic/active programs. So what is that? One is passive information and dynamic/active programs. Fine. Yeah, current status of applet technology. What is the current status of applet technology? Look, in the early days of Java, applets were crucial part of Java programming. They illustrated the power and benefits of Java, added an exciting dimension to web pages. Although there are still applets in use today, over time they have become less important. Over time, they have become less important. Look, with the advent of JDK 9, applets are being phased out with other mechanisms supplying an alternative way of delivering dynamic content onto the web. See, beginning with JDK 9, Java's support for applets has been deprecated. In the language of Java, deprecated means that a feature is still available but flagged as obsolete. It's flagged as obsolete. A deprecated feature is subject to removal in a future release. It is subject to removal in a future release. Thus, deprecated features should not be used for new code. Deprecated features should not be used for new code. That is the convention. Fine. Yeah, current status of applet technology continued. Our discussions on applet technology is still continuing. Look, various alternatives to applets are now in place, with arguably the most important being Java Web Start. Java Web Start enables an application to be dynamically downloaded from a web page. Look, the difference is that the application runs on its own, not inside the browser. Thus, it does not rely on the Java plugin as the applet did. Java Web Start is a deployment that works with many types of Java programs. A brief introduction to Java Web Start can be presented later in our discussions. Fine. Yeah, security. Now we are discussing the concept of security. As desirable as dynamic, networked programs need be secure too, because they can also present serious problems in the areas of security and portability. Obviously, a program that downloads and executes automatically on the client computer must be prevented from doing harm to the system. It must also be able to run in a variety of different environments and under different operating systems. As you can see, Java solved these problems in an effective and elegant way, in an efficient and elegant way. Security continued. We are continuing our discussions on security. Look, as you are likely aware, every time you download a normal program, you are taking a risk, because the code you are downloading might contain a virus, a Trojan horse, or other harmful code. At the core of the problem is the fact that the malicious code can cause its damage because it has gained unauthorized access to system resources. Look, that's it. It has gained unauthorized access to system resources. Look, for example, a virus might gather private information, such as credit card numbers, bank account balances, and passwords by searching the contents of your computer's local file system. In order for Java to enable programs to be safely downloaded and executed on the client computer, it was necessary to prevent them from launching such an attack. So such an attack should be prevented. Fine. Java achieved this protection by enabling you to confine an application to the Java execution environment and prevent it from accessing other parts of the computer. We will explain it in a moment. The ability to download programs with a degree of confidence and with a degree of confidence that no harm will be done may have been the single most innovative part of Java. The single most innovative part of Java. Yeah, we are coming to the topic of portability. Portability, look. Portability is a major aspect of the internet because there are many different types of computer systems running on a variety of operating systems connected to it. If a Java program were to be run on virtually any computer connected to the internet, there needed to be some way to enable that programs to execute on different systems. In other words, a mechanism that allows the same application to be downloaded and executed by a wide variety of CPUs, operating systems, and browsers is required. Obviously, it is not practical to have different versions of the application for different computer systems. The same code must work on all computers. Therefore, some means of generating portable executable code was needed. As you can see, the same mechanism that helps ensure security also helps create portability. That's it. Yeah, Java's bytecode technology. That means write once, run anywhere. See, the bytecode technology is normally interpreted as write once, run anywhere. Look, we'll go through that. The protocol that allows Java to solve both the security and the portability problems just described is that the output of a Java compiler is not an executable code. Rather, it is bytecode. It is not simply an executable code, but it's a bytecode. Bytecode is a highly optimized set of instructions designed to be executed by the Java runtime system, which is called the Java Virtual Machine or JVM, Java Virtual Machine, known as simply JVM. In essence, the original JVM was designed as an interpreter for bytecode. Translating a Java program into bytecode makes it much easier to run a program in a wide variety of environments because only the JVM needs to be implemented for each platform. That's the greatness. Yeah, Java's bytecode technology or write once, run anywhere is again continued here also. We are continuing our discussions on Java's bytecode technology. Look, once the runtime package exists for a given system, any Java program can run on it. Remember, although the details of the JVM will differ from platform to platform, all understand the same Java bytecode. See, all understand the same Java bytecode. Next, on the other way, if a Java program were compiled to native code, then different versions of the same program would have to exist for each different types of CPU connected to the internet. This is of course not a feasible solution. Thus, the execution of bytecode by the JVM is the easiest way to create truly portable programs. That is why Java uses the slogan, write once, run anywhere. So that's why we have this slogan, write once, run anywhere. Fine. Yeah, the fact that a Java program is executed by the JVM also helps to make it secure. Because the JVM is in control, comma, it manages program execution. Thus, it is possible for the JVM to create a restricted execution environment, comma, called the sandbox that contains the program, comma, preventing unrestricted access to the machine. Unrestricted access to the machine. Safety is also enhanced by certain restrictions that exist in the Java language. Fine. That's very fine. See, next. In general, when a program is compiled to an intermediate form and then interpreted by a virtual machine, it runs slower than it would run if compiled to executable code. However, with the Java, the trade-off is negligible only. See, however, with Java, the trade-off is negligible only because bytecode has been highly optimized. The use of bytecode enables the JVM to execute programs much faster than you might expect. And especially in this modern age of fast CPUs, this trade-off is very, very little, negligible. Practically, it is negligible. Fine. Yeah, the JVM and the JIT. JVM and JIT. Although Java was designed as an interpreted language, there is nothing about Java that prevents on-the-fly compilation of bytecode into native code in order to boost performance. For this reason, the hotspot technology was introduced not long after Java's initial release. Hotspot provided a just-in-time, that is JIT, just-in-time compiler for bytecode. A just-in-time compiler for bytecode. When a JIT compiler is part of the JVM, selected portions of bytecode are compiled into executable code in real time on a piece-by-piece demand basis. On a piece-by-piece demand basis. Okay, fine. It is important to understand that the entire Java program is not compiled into executable code at once. It's not being compiled into executable code at once. In one stretch, look. Instead, a JIT compiler compiles code as is needed during execution. Furthermore, not all sequences of bytecode are compiled. Only those that will benefit from compilation. The remaining code is simply interpreted. However, the just-in-time approach still yields a significant performance boost. Even when dynamic compilation is applied to bytecode, the probability and safety features still apply, the portability and safety features still apply, because the JVM is still in charge of the execution environment. Fine. Yeah, a mention of server-side Java, servlets. We are now discussing a little bit about servlets. It's on the server-side Java. Look, the Java universe is broadly divided into client-side Java and server-side Java. In fact, Java became so famous because of its capabilities in managing server-side programming. Because of its capabilities in managing server-side programming. So many new technologies on server-side Java emerged soon after the release of the client-side Java. Client-side Java was mainly used for creating GUI, graphical user interface, GUI-based applications. Till the advent of Java, GUI-based applications were done using Microsoft's technologies like VC++, Visual C++. But client-side Java made GUI application development much simpler and easygoing, unlike the more complex VC++. See, unlike the more complex VC++. Fine. But when Microsoft introduced VB-based GUI application frameworks, the entire picture changed. Programmers arguably choose VB-based GUI application frameworks as the de facto standard to create GUI applications. GUI applications were being done or created using VB based. It was no longer used, it didn't use VC++, but VB was much simpler and straightforward and very much elegant. So people shifted to VB based GUI application frameworks. So the importance of Java's client-side mechanism or client-side Java's power and popularity just got diminished because of the advent of VB-based GUI application frameworks. But Java became great because of its server-side activities. So Java became very famous because of server-side technologies. We will have a very elaborate discussion on that later. Fine. Now, that's it. Yeah, it was at this point in time Java shifted its attention from the client side to what is called the server side. From client side, Java shifted to what is called the server side. A plethora of new technologies followed from the house of Java. Among them, servlets is the foremost. A servlet is a small program that executes on the server. Servlets are used to create dynamically generated content that is then served onto the client. Fine. For example, an online store might use a servlet to look up the price for an item in a database. The price information is then used to dynamically generate a web page that is sent to the browser. Although dynamically generated content is available through other technologies like CGI, means Common Gateway Interface, the servlet offers several advantages, including increased performance. That's the power of servlets, including increased performance. Fine. Yeah, servlets continued. Because servlets, like all Java programs, are compiled into bytecode and executed by a JVM, they are highly portable. They are highly portable. Thus, the same servlet can be used in a variety of different server environments. The only requirements are that the server support the JVM and a servlet container. That's all.